Dear student of class 11, this video is also of mathematical induction, but the problems are different. Now prove by using the mathematical induction n plus 1, n plus 2 is a multiple of 6. Now that means the question is this: you have to prove n plus 1, n plus 2 is a multiple of 6. Now what is the meaning of the term, given term is a multiple of 6? 6 itself is a multiple of 6, then the multiple of 6 is 12, then 18. These are the multiple of 6. 6, 12, 18, 36, 48. These are the multiple of 6. But you have to prove these things using the principle of mathematical induction. Now I'll consider that Pn is equals to n plus 1 into n plus 2. Now the first step that I'll apply over here, putting n is equals to 1. Then P1 is equals to 1 into 1 plus 1 into 1 plus 2. This is 2 into 3. This is 6. 6. That is, which is a multiple of 6. Which is a multiple of 6 itself. 6 into 1 is 6. That means P1 is true. Same way, putting n is equals to m. Now what you will get? Pm is equals to m plus 1, m plus 2, which is also a multiple of Pm is always true, which is also a multiple of 6. Therefore, the statement, P1 is true, then Pm is also true. Now next is the third step. I'll substitute n is equals to m plus 1. Whether the n plus 1 is a multiple of 6 or not, that you have to verify. Putting n is equals to m plus 1. Now then I'll substitute over here. Pm plus 1 is equals to m plus 1, m plus 1 plus 1, then m plus 1 plus 2. This you have to prove this is a multiple of 6. Now in this type of problem, over here, in case of Pm plus 1 series, that you have to manage this Pm series. Try to find the Pm series over here. Now then m plus 1, then m plus 2 into m plus 3. Now I'll just try to manage this quantity over here, the m series. This quantity must be present over here, that you have to adjust. Now sir, m plus 1 is present, m plus 2 is present. What we required? M. So I'll multiply m plus 3 by these two quantities. If I multiply this m by these two quantities, then we'll get m into m plus 1, m plus 2. Then plus 3 into m plus 1 into m plus 2. What I did over here, I multiplied m by these two quantities and 3 by same two quantities. Now sir, it is already proved that this one, m into m plus 1 into m plus 2, m into m plus 1 and m plus 2 is Pm. It is already proved that the Pm is a multiple of 6. That means this is proved. Whether this quantity is multiple of 6 or not, that you have to verify. Then n is equals to 1 means n is equals to m is also 1. If you substitute over here 1, what you will get? The remaining part, 3 into m plus 1 into m plus 2. Whether this quantity is a multiple of 6 or not, substitute the value of m. Any number. 1, I'll consider 1, the easy one. 3 into 1 plus 1 into 1 plus 2. 3 into 2 into 3. So 3 is a 9, 9 2 is a 80. If you substitute any number over here, that you will get a number which is multiple of 6. This one is multiple of 6, this is multiple of 6. And sum of the two numbers which are multiple of 6 means the sum is also multiple of 6. So we can write n plus 1, n plus 2. This is a multiple of 6. Now then, which is also a multiple of 6. This I did a raw form. This one is a raw form. Then the conclusion, therefore, Pm is true, then Pm plus 1 is also true. Therefore, the given induction is a multiple of 6. This is proved. Now the next question is, it's the same kind of questions, but what you have to prove, it is divisible by 2. One I did, the previous one was multiple of 6. Now this is divisible by 2. Using the principle of mathematical induction, the given expression is divisible by 2. Now I'll consider that Pn is equals to 3 to the power 2n minus 1 plus 3 to the power n plus 4. Now then, same method, putting n is equals to 1. P1 is equals to 3 to the power 2 into 1 minus 1 plus 3 to the power 1 plus 4. Now after the simplification, it is 3. 2 into 1 is 2. 2 minus 1 is 1 plus 3 plus 4. 3 plus 3 plus 4 is 10. And 10 is, which is divisible by 2. Therefore, P1 is true. Now next, putting n is equals to m. Then Pm is equals to 3 to the power 2m minus 1 plus 3 to the power m plus 4, which is also divisible by 2. The answer is always true. In the statement, therefore, P1 is true, then Pm is also true. The next step is putting n is equals to m plus 1. Then Pm plus 1 equals to, I'll substitute over here, 3 to the power 2 into m plus 1 minus 1 plus 3 to the power m plus 1 plus 4. Now to adjust these things, now again the same method I'll apply, that you have to manage the m series, this quantity in the series. For that, I'll simplify this. 3, open this bracket, it is 2m plus 2 minus 1 plus 3 to the power m plus 1. What we require? 3 to the power m only. Then we can write 3 to the power m into 3 to the power 1 plus 4. Now then, what we require? 3 to the power 2m minus 1. Then I'll write 3 to the power 2m minus 1 plus 2 plus 3 into 3 to the power m plus 4. This calculation is a little bit tough, try to understand. Now then, I'll use MSS. I'll make this 2m minus 1 one index and 2 is another index. So I'll break this to quantities. Now then, we can write 3 to the power 2m minus 1 into 3 squared. Base is same, the index are different over here. So 3 to the power 2m minus 1 is one index and another index is 2. Then over here it is plus 3 into m plus 4. 3 square is 9 into 3 to the power 2m minus 1 plus 3 into 3 to the power m plus 4. Now then I'll adjust this quantity over here. 3 to the power 2m minus 1. Only one quantity is required. But over here with us it is 9 quantities are there. So I'll write only one. 9 into 3 to the power 2m minus 1. We can write 3 to the power 2m minus 1 plus 8 into 3 to the power 2m minus 1. 8 plus 1 is 9. Now over here we required only one, but we have with us it is 3 quantities. So I'll write 3 to the power m plus 2 into 3 to the power m plus 4. Now then I'll just write the pm series over here from this. 3 to the power 2m minus 1, then plus 3 to the power m, then plus 4, plus the remaining quantities are 8 into 3 to the power 2m minus 1 plus 2 into 3 to the power m. Now this quantity is represented by pm, and the pm is already it is proved that the pm is divisible by 2. Now from the remaining expression, from these two expressions, I'll take 2 common. If I take 2 common, what remains inside the bracket? 4 into 3 to the power 2m minus 1 plus 3 to the power m. This is divisible by 2. 2 into anything is also divisible by 2. 2 is over here. This 2 is divisible by 2. So 2 into anything is also divisible by 2. Therefore, which is also by 2. Therefore, pm is true. Then pm plus 1 is also true. Therefore, the given induction is it is proved. Now try to understand this pm plus 1. Now in this video I'll send these 2 questions only. The related questions I'll solve and send it to you. Thank you.